To understand this practice, it is necessary to know what is friction. It is defined as the force of a surface opposed to the movement. There are two types of friction, kinetic and static. The first one is when an object is moving. The second one is the force that opposes the starting of movement. The formula is friction equals mu coefficient of friction times normal force, where normal force is the force that is perpendicular to the surface force acting on the object, and the coefficient of friction is the dependence quantity of a particular surface. The dependent variables are the angle of inclination and the coefficient of friction, and the independent one is the material of the surface.
Well, in this first experiment we measured the angle using a 10 pesos coin. I was the one who was registering the angles, and in the first attempt we obtained an angle of 30 degrees. Then we obtained two angles of 15 degrees. And in the last 6 repetitions we obtained angles of 20 degrees.
The results of the experiment were obtained through the calculation of tangent of the angle, giving us a number between 0 and 1. Almost all the results were the same. In the first experiment, the one with the 10 pesos coin, we obtained firstly an angle of 30 degrees, which means a coefficient of friction of 0.57. Then we obtained 2 times an angle of 50, a friction coefficient of 0.26, and finally we get an angle of 20 degrees, a coefficient of friction of 0.36.
The second object that we slipped on the ceramic was a vessel with cookies, and during the 10 repetitions we had 10 angles of 20 degrees.
In the second experiment, we obtained also an angle of 20 degrees, a friction coefficient of 0.36 over all the experiment.
The last object was another coin, but this one is one of 1 peso, and we obtained all the angles equal. That's it, 10 angles of 20 degrees.
In the third experiment happened the same.
The first thing that we shall know is answer the following question. How is obtained the coefficient of static friction using an angle? Well, to answer it, we have to represent our experiment or movement of the object in mathematical way, that is making a free body diagram. With this graphic, we should identify the directions and the magnitudes present in the motion. So in this motion, we identify 3 forces. One of them is static friction, that is the purpose of this experiment, and the rest are called normal force and weight that maintain an equilibrium according to the first Newton law. Each force has different direction. For example, normal force goes up, static friction goes opposite to the motion, so we represent it in its negative axis, and weight that goes down, but with a certain angle that we were changing in the experiment to allow that the object slides. So weight will not be only in the y-axis, it will be between its negative axis and y-negative axis. So we have to compose using trigonometrical functions to make possible add all the force in y and x. So we will have weight times cosine of the angle and weight times sine of the angle, and each must be placed in the correct axis. We start with the sum of forces in y, in which we have normal force and weight times cosine of the angle, and they should be equal to 0 because the v is not moving. So only we have to isolate weight because it is negative, and we will obtain that normal force is equal to positive weight times cosine of the angle. In x-axis we have static friction and weight times sine of the angle, so the same happens with the previous operation. static friction will be equal to positive weight times sine of the angle. But we want to know the coefficient of static friction that shows us the relation between normal force and static, so we will use the next formula. And we are solving for the coefficient, so we have the static friction divided by normal force, and if we substitute, we have weight times sine of the angle divided by weight times cosine of the angle, in which you can see that the weights will be cancelled, and only remains the functions that can be summarized by only one function called tangent. So with tangent we calculate the coefficient of static friction because it measures the limits in which an object will be at rest until another force greater than weight acts on it, and the object will be able to slide. So when we increase the angle, the number of force and weight decreases, causing that the forces in y-axis acts as a force that pushes the object, and it demonstrates that the static friction will not be affected by mass because weights will be cancelled. This is because in static friction there is no accelerations because the object gets at rest.
According to Asapol, the coefficient of static friction in ceramic is not greater than 0.32, and we obtained in an experiment a coefficient of 0.36. This is because it depends on certain factors. It can be used to factor that was not very precise, so the angle that we measure is not a fixed value. Another thing is the state of the surface and its impurities, because sometimes the object got stuck and we increase the angle, but it does not slide down, and it can affect the measurements. What do we learn and what do we know? It is kind of curious how all the different materials in which we are in contact during our daily life have certain properties that allow the things to function or move in the way that they do. The coefficients of friction are very important because if they would not exist, many things could not function in the way that it need to do, and we couldn't know it in the way that we are used to do.